Today's lesson is on commercial wall systems, so make sure that you add these to your notes. First off is different wall classifications. We have load-bearing walls and non-load-bearing walls. Load-bearing walls are walls that support vertical loads other than its own weight. Non-load-bearing support only its own weight. So examples of that, a load-bearing wall would be like the walls that are surrounding all the outsides of your house. Those are typically all load-bearing walls. They would support roof, above, or floors. You probably have some walls inside your house, though, or maybe inside your apartment, wherever it is that you are living. There, you could actually remove some of those walls, and it would not actually cave anything down. The roof would stay intact. Everything would stay just fine. Those are called non-load-bearing walls. They support only their own weight, and they're typically used as partition walls just to separate interior spaces. So make sure when you're adding these things to your notes, you just note what a load-bearing wall is versus a non-load-bearing wall. We don't need to write all of these things down, but just kind of the basics to define the difference between them. So load-bearing walls. We're going to look at typical construction materials. Low-rise commercial construction, 3 stories or less, can be similar to residential construction, which means that they might be made out of wood. You could do some precast concrete or light gauge steel for load-bearing walls. Other common commercial wall materials are cast in place, and we talked about that earlier in the year, as well as tilt-up concrete and concrete masonry units. So we're going to talk about each one of these in detail, so we'll come back to these as we move forward. So first thing, though, is concrete. So this is sort of the breakdown of what is in concrete. Concrete is 6% air, 11% cement, but most of it is gravel and crushed stone. And sorry that this image is a little bit grainy here, but that's what it says, gravel or crushed stone. And then you have a bunch of sand, 26% sand, 16% water. That is generally what concrete is made out of. So it's only roughly about 10% cement. The rest of it is gravel and sand. Advantages of concrete. Strength, especially in compression, that is a huge advantage. It is very durable, fire resistant, pest resistant, rust resistant, low maintenance. It's also energy efficient because it's a thermal mass. Once it gets heated up, it actually stores that heat energy. So these are some of the advantages you have. You could say advantages over wood and over steel. This is some advantages concrete has. It's also very expensive. That would be a disadvantage. Green concrete, you can get LEED credits, LEED credits for using concrete in specific ways. It can improve energy efficiency, can reduce VOCs using different materials versus concrete versus other materials. So we don't need to add these specifically to our notes. This is some very specific details. I just wanted you to know. So cast in place concrete is when we pour it directly into it. So you can see they're pouring the concrete directly here. All of the rebar, the reinforcement bar is there. We're pouring it directly on site. And again, the rebar, the steel bar, is used to improve in the tensile and bending strength, because concrete is really, really strong in compression, but it's really weak in tension, which is like if it's bending or being pulled apart, concrete can just crack. But when it's being compressed together, super, super strong. This is what a typical cast-in-place concrete construction wall would look like. You would have these rebar chunks that are kind of in a grid-like formation. Some are going horizontal, some are going vertical, and then we pour the concrete in there. Well, how does the concrete stay? Well, you have these forms that are in place. This is insulation. This is like styrofoam. On one side, you have styrofoam on the other side as well, and then the concrete just kind of fills in that slot right there. Then if you want to add what's called a veneer, or like you want to add a facade, something that's like in the outside of the wall to make it look nice, then you might put masonry. This is like bricks, something like that. And then you have these things called masonry ties that will tie it actually to the wall itself so that the bricks don't just fall over. Someone can't just karate kick that. A weep hole is what you cry in when your wall falls over. It's also where water will seep down into it. That's why it's called a weep hole, because water will actually can go down into that. Cast in place concrete walls with insulating concrete forms. That's that styrofoam insulation. Here's an actual picture of it. This is the styrofoam right here, styrofoam here. You can't see on the inside of that, but it's open, and that's where we pour the concrete. So that's kind of what we were showing here, is this insulation here, and then we pour that concrete in there. These are insulated concrete forms. They actually snap together. It makes putting the concrete wall together really, really quick and easy. These are some examples of cast in place concrete. You have the Burj Khalifa in Dubai. This is the tallest building that people can actually be in, and where there's occupancy. Anyway, it's like 2,700 feet, something like that. It's gigantic. I actually had the opportunity to go way up right around here in this building on my way to Africa, and we stopped over in Dubai. Pretty amazing views up there. Then there is tilt-up concrete. So the difference between cast in place and tilt-up is tilt-up concrete. It's poured on site, and then they actually take these walls and then they tilt them up vertical, or they just kind of have a crane and they set them in place, but they are all pre-made. So that is one thing you need to note in your notes. Tilt-up concrete are pre-made concrete walls, where cast in place are made actually on site. Tilt in place are done at a manufacturing facility. Now, if this is the manufacturing facility, this might be the wall that's like being created on the ground. It's formed, and then they stack them all together and they bring them into the site. And this is an example of one that's being tilted up and put into place. So they can be formed into a lot of different shapes and sizes. They can be treated in different ways. They're really quick to design. They can have lots of different looks on them. And so here is a tilt-up wall, but what they're doing is they're actually laying brick, this brick facade. These are not actually full-size bricks. They're really, really thin, and they're actually putting them on the tilt-up wall first, and then they tilt the wall up, and then the entire thing is bricked. Super, super clever. And then here we go. We're forming this wall in this sort of rounded shape, this curved shape. So when we tilt it up, we get this really cool curved front. So that's how you get those neat curved looks on the front of some of these commercial buildings that we might see. And then after you do it, then you also need to make sure that you put your finger in the picture. Okay, now this is an example of what it actually looks up, the tilt-up concrete wall. Once it's up, you're probably wondering, well, why doesn't it just fall down? Well, that's a great question. Let me answer that. So we tilt this thing up, and there's a bracket down here. This is the footing that's put into place. And there's this metal bracket right here, and it's kind of hard to see, but there is it's kind of different hashed line there. That metal bracket is there, and then we actually bolt to this metal bracket. So yes, that is probably not enough just to keep it in place. Well, in the tilt-up concrete, as this is poured, this concrete layer here, they also have a steel rebar that kind of sticks out right here before we do all this dirt backfill. So it's just this footing and this wall with this big piece of rebar kind of sticking out so that you can trip over it. But it's not designed to trip over. It's actually designed to tie in the floor. So now we backfill all of this dirt in here. We probably have some gravel, and now we pour the concrete floor, and that concrete floor then is tied into this rebar. So now we have rebar into this concrete floor that's also into this wall. So that makes it very, very, very secure when they have that rebar in there and they have it bolted to the footing. So some examples of tilt-up concrete. Here's just one building, Austin Research Center. You have the Boca Village Corporate Center in Boca Raton. And then this one shows some really cool curved surfaces. So remember, you probably brick these beforehand, and then you can just tilt them into place, and they're put onto these columns. Pretty cool. And then here's a really cool building that is all slanty. All right, concrete masonry units. This is what our school is largely made out of, at least on the inside, those interior walls. They're just hollow blocks stacked and grouted. The grout is the stuff that goes in between the blocks. They call that grout. And these are typically load-bearing walls that are reinforced with steel bars to improve the strength. So you put a steel bar every so often in these, and then you fill those with concrete, and that makes it really, really strong. So here's another one that's being built. You can see the steel kind of coming up at intervals. Here, this is a really, really blurry person putting a concrete masonry unit in. So an example here, you have this rec center, you have this big commercial building under construction, and you can see the exterior of it has this kind of rough look because it makes it look cool, rough. And here's another one. This is tilt-up and concrete masonry unit. Concrete masonry units in certain parts, tilt-up in other parts. So then we get into non-load-bearing walls. These support only their own weight. They're typically used as partitions to sort of separate. And there are a lot of non-load-bearing walls in the Centaurus High School, but they're made with concrete masonry units because of fire code, but they're actually not supporting anything. They can be removed with no problem whatsoever because the beams that are going vertical and the columns that are going across are actually supporting the majority of the load. But if we're looking at non-load bearing walls, that means you can remove them completely and nothing falls down. So they're usually used as partitions. You can use wood to do this, light gauge steel framing. You can use, as I said in Centaurus, as concrete masonry units. And once this little dialog box goes away, you can also see curtain walls down at the bottom. So we'll talk about curtain walls here coming up. But you can see here, the large frame is built, and the whole thing is standing. But once this is done, you're going to want to put partition walls to maybe put offices. Those walls can be removed at any time and the building's not going to fall down. That is a non-load bearing wall. And this is another example of a non-load bearing wall. It's just put into place as a partition. Now let's look at curtain walls. I love curtain walls. These are non-load bearing walls attached to the exteriors of buildings, sometimes in the interior, but they're usually composed of glass and metal, and they provide visual appeal. So this is what is called a facade. That is F-A-C-A-D-E. Facade. Say it with me. Facade, facade, facade. And that is just what is the appearance of the building. So a curtain wall gives a really cool facade exterior appearance because it's just this glass. Curtain walls do not support any loads at all because they're made out of only glass. And so that means that this entire frame needs to support itself. And then we have these steel frames in the middle because you can't make glass that large. And that actually supports that exterior. So it makes it look really, really cool. This one is that tilty building. So you have this steel frame, but then we have this really neat curtain wall that's diagonal. That is a really cool facade. It's a curtain wall all of glass. So anytime you see anything that's all glass, then that is a curtain wall. It's non-load bearing. And it's just to make the appearance look really, really neat. So here we have another one, Trump Tower here. This is, I believe, is in Chicago, I think. And this one is all glass facade. A lot of buildings and cities will have this all glass facade, which means that they are non-load bearing walls. The entire frame is made out of a steel or concrete encased steel structure that's really strong, doesn't need any other supports, but then the glass makes it look super cool. And there we go. So commercial wall systems, I hope you were able to get all of that information down. Remember, you can always pause. You can always go back and look at it if you need to. But you have load bearing versus non-load bearing. Our load bearing walls are the low rise, the green concrete. Remember, you can have credits from green concrete. But then the three main ways to construct them that we looked at were cast in place concrete walls, tilt up concrete walls, and concrete masonry units, which are also called CMU. So make sure that you have information on each one of these. And then finally, the non-load bearing walls were the curtain walls, which are all non-load bearing again, and can be used to create a really cool facade of the exterior of a building. And that's all we got.